Solving simultaneous equations means that you find the coordinates where this line of 4x plus 3y equals 14 crosses over with 5x plus 7y equals 11. So that's what that actually means. That's what you're actually finding by solving them. So to solve them, we first of all need to get either the numbers before the x is the same or the numbers before the y is the same. So I'm just going to pick the number for the x's. So a multiple of 4 and 5 is 20. So I need to multiply the top one by 5 to get 20x, and I need to multiply the bottom one by 4 to get 20x. So every single thing in this top equation needs to be multiplied by 5. So 4x times 5 is 20x, plus 3y times 5 is 15y, equals 14 times 5 is 70. And then this bottom equation, everything needs to be times by 4. So I get 20x again, plus 28y equals 44. Now, I need to either get rid of the x's or get rid of the y's. Something needs to disappear, because otherwise I can't solve these. So I'm actually going to take away the top equation. To do the top equation, take away the bottom equation. Because this means I'm going to do 20x, take away 20x, and I'm going to be left with nothing. So the x's will disappear, or be eliminated, which is why this is called the elimination method. So 20x take away 20x is nothing, so 0. 15y take away 28y is negative 13y, equals 70 take away 44 is 26. So negative 13y equals 26. Well, if I divide both sides by negative 13, y must equal how many negative 13s go into 26? So the answer is negative 2. So I found my y value. So remember, that's part of a coordinate. So I know that my second number on my coordinate would be negative 2, the lines where they cross. Okay, so it would be negative 2, but I need to find the x part. So I pick either of these equations. It doesn't matter which one I pick. So let's just take the top one for convenience. So 4x plus 3y equals 14. We've just worked out that y is negative 2. So we've got 4x plus 3 lots of negative 2 equals 14. So let's make it easier. 4x, well, 3 times negative 2 is negative 6 equals 14. And now you just have a linear equation that you can solve using stabilizers. So we need to find x. So to get x on its own, the 4 is only affecting the x, whereas this negative 6 is affecting the whole thing. So we need to get rid of the negative 6, or take away 6, so add 6 both sides. The add 6 and take 6 cancel each other out. So I'm left with 4x equals 20. Well, 4x, that means 4 times x equals 20. So I need to get rid of the times by 4. So I need to divide by 4 both sides. I can cross out the opposite, so divide by 4 and times by 4 cancel each other out. So you're left with x equals 20 divided by 4 is 5. So my other part of the coordinate would be 5. Otherwise, if they don't ask you for a coordinate, then your solutions are just x equals 5, y equals negative 2. Okay, so looking at one more, which is slightly more complicated, only requires one extra step. So we need to start looking at the fact that we've got the x's, the y's, and a value on the left-hand side. So we need to get the number on its own onto the right-hand side. So that would just be x plus 2y equals negative 10. And that would be 3x take 5y equals 14. So now we've got the numbers on the right-hand side and the x's and y's on the left. We can now start to look at making the number before the x is the same or the number before the y is the same. So remember, x on its own is just 1x. So I'm going to pick to make the x's the same, the number before the x the same this time. And the reason I'm going to do that is because if I did the y's, I've then got to deal with this negative symbol, which I don't want to do. So a multiple of 1 and 3 is 3. So this bottom equation is already 3x, but that top one I need to multiply it by 3 to get 3x. So remember, everything needs to be multiplied by 3. So we get 3x plus 2y times 3 is 6y, and then negative 10 times 3 is negative 30. And then I've got the bottom equation, and this bottom equation just stays the same because we've already got 3x that we want. Let's take away 5y equals 14. So now, if I was to add them together, I'd get 3x add 3x is 6x. So we definitely don't want to do that because we want to eliminate one of the letters. So I need to subtract, and I do the subtraction because 3x take away 3x gives me 0, which is exactly what I wanted. 6y take away negative 5y. So when you take away a negative, that means 6y add on 5y, so we get 11y equals, and then negative 30 take away 14 is negative 44. Okay, so now we can figure out what y is. So we can divide both sides by 11 to get y on its own. So we get y equals, well, negative 44 divided by 11 is negative 4. And so remember, if I was asked to write the coordinate, my second value in the coordinate would be negative 4. But now I need to find my x value. So I need to pick one of the equations, and I'm going to pick the top equation because it's already got 1x in. So I'm going to pick 1x plus 2y equals negative 10. But I already know, well, I've got one lot of, sorry, I haven't found the x yet. I've got one lot of x plus 2 lots of negative 4 equals negative 10. So now I've got 1x, 2 times negative 4 is negative 8, or take away 8 equals negative 10. So now I've got a normal linear equation, which I need to use stabilizers. So I need to get rid of the take away 8, so I can add 8 to both sides. They're opposite each other, so cancel each other out. So I get 1x equals negative 10, add 8 is negative 2. And 1x equals negative 2 is the same as x equals negative 2. So my final part of the question, if I needed the coordinate, that would be negative 2. If I wasn't asked for the coordinate, then my final answers would just be y equals negative 4 and x equals negative 2.